So hello guys, welcome back to another video, and in today's video we'll be solving this question, lead code question number 62, unique paths. Guys, first of all I wanna just clear out one thing. To be honest, I love teaching, but there are still better coder than me who can teach you guys. But to be honest, while I'm explaining, so I also kind of learn from it. I also understand it because when you explain, I go more into the depth of it. So when I'm teaching you, basically, uh, if I'm making this video and explaining you things, it's not that I'm the master or whatever. I am also a student because I want to learn from it. And even when I am teaching this, I am taking it as a learning. I hope this made sense. But even if it didn't made any sense, I don't know if it made or not. I know because actually dev guys are very cracked and boring. Most of the time I'm solving questions and stuff. Oh, never mind. Okay, guys, so this is the question, and it is a 2D DP problem, as you can see. So I'll just read out the problem statement. There is a robo on a M cross N grid. Okay, the robo is initially located at the top left corner. Okay, here it is located. The robo tries to move to the bottom right corner. Okay, that is grid M minus 1 and minus 1. Okay, this is the target. The robo can only move either down or right. Okay, it can go either down or right. Given two integer m and n, the m and n, okay, the number of rows and column, return the number of possible unique paths. So number of possible unique paths we have to tell, okay, that the robo can take to reach the bottom right corner. Okay, I think this is a very simple question. I'll just, you know instead of telling you first the recursive approach, I just want to tell you the DP approach first. First of all, basically, let's just explain what the problem is actually. Okay, so the problem is basically the robo is here. The robo wants to reach here, of course, using the grid. So it can only move in two direction, which is right or down. Okay, so basically, if the robo wants to reach here, it can either go from this path, taking this right, and then this, or it can go from here to here. So to reach this path, to reach this block, can we see there are actually two ways: this, and this one. Okay, so in order to reach this target, it could have many ways. Okay, but if we break it down into a sub problem, basically into a smaller grid, this and this, and we have to reach here. Okay, and our robo is here. Okay, this is our robo. So it can either go from this right, then it can go down, or it can go down and then right. Okay, so can we see a pattern? Basically, to reach this guy, we are coming from this block, or we are coming from this block. So can we say, like, there are two approaches to come? So if I say target, this is the target I have to reach. So can I say I am coming from I minus 1th row, okay, and jth column? Because if I minus 1 is basically, if we take I minus 1 as rows, so column is this one. Okay, we are coming from here to here, or we can go from this is, wait a second, yeah, so this will be j minus 1 and I. Okay, okay, so basically this is the recursive relation. I hope it is very much clear. And still, if it is not clear, then just stay with me, guys. I'll first code it down and then I'll explain you again. First of all, instead of starting with the recursive approach, I want to start with the DP approach, which is basically the tabulation method. Okay, so as it is a 2D DP problem, so first we'll define the state. Okay, define DP state, which is DP of to 1 into m. Now why did I define the state dp1? Because at every we can initialize our grid with 1, because to go from right or left, the minimal step is 1, right? The minimal step is 1. For example, if this is a block, okay, this is just a single block. Now our robo is here. So to reach this guy, you need one step. To reach this guy, you need one step. Basically, number of ways. Okay, so we can initialize it with ones, not with zeros. I hope it is clear. Not with zero, not with -1. We have to initialize our grid with 1, because from one block to another block, we uh, we have to take the number of ways which can be is 1, right? So I hope I am clear here. Now for I, first we have to loop in the columns, in the rows, sorry, yeah, in the rows. First we have to be in this row, so rows we have m. Then inside there will be again a nested loop, which will be for I in range 1 comma n. Now we'll update our recursive relation. It will be dp I minus 1 and j, and then plus. This is one of the way. Okay, now the other way of reaching it is from gth minus 1. Basically one we are taking from the row, one and one we are taking from the column, right? So two ways. So we'll write both the two ways. Now return dp of m minus 1 and let me see if it's right or not. First it is into the row, yeah, into the column, yes. I hope this should work. Invalid syntax. Again there's a problem. Sorry guys. Now how am I doing so much mistake? I'm so sorry guys. Actually I recently broke up with someone, and it's affecting my life. Maybe when she was with me, then it was affecting more. By the way, I'm just kidding. Crack devs don't have any girlfriend. Yeah, sorry. So I hope this solution is clear. This was basically the tabulation method. What we did is we initialized the grid of 1, and then we looped through the grid, and there are two ways to reach a target. Two ways. One is from the previous row and that column, and other is from the previous column and the existing row. Okay, now also I want to share recursive recursive solution also. I think there is no point of like writing down the recursive whole recursive thing here. I'll just explain it in the code, right? We initialize I comma j, then we take base condition 1, base case 1, which is if I is greater than or equals to what, m, okay, or j is greater than equals to n, then what, then return 0, because it is out of bound, right? And other base case, if this is base case 2, if I equals to m minus 1, if it is on the last state, or j equals to n minus 1, right? Then return 1. Now paths, we'll just call the recursive call, yeah, paths, which will be I plus 1 comma j plus paths j comma I plus 1. uh, let's see. Yeah, now it will give TLE because we have broken down into the sub problems, but the time complexity is basically O of 2 to the power m into n. So it will give a TLE, and for TLE, I'll show you a Python trick too, which you can use, but you should avoid it. Basically, the trick is we are creating an automatic dictionary from tools. CSC, CSCHE, right? Now, yeah, the rate error. I hope this works now. Yeah, so it will work now because the Python has automatically created a dictionary for me of storing the answer. Of course, you should avoid this. To avoid this, we can also uh, do other methods, like we can other methods basically memoization. We can use a dictionary. Also, uh, we can also use a DP array to store, like wait, I'll just show do n. Ah, in range m. Okay, now these are the base cases. Now if dp of I and j is not equals to -1, then return dp of I and dp of I j. Otherwise, uh, dp of I and j equals to this, and I hope this works. Yeah, this also works. Basically, what I did is here I created a 2D DP array to store my sub problems. This is basically recursion. In recursion, I used memoization. So we can also say it is top-down approach, as we started from the bigger from the sub problem, and as we are going through our target problem, basically as we are going through our answer, we are storing all the results, which uh, which we need further. So basically, instead of recomputing these sub problems, we are just storing our answers in a single go, and then we are taking out the values from there. Okay. So now in memoization, you can also use dictionary to store, but I think dictionary, that part you can try yourself. And to be honest, I like this thing more. And so these were I like this thing more, and I think these this was the question, right? And you should try it once. So we did it using three methods actually. First we did recursion, then we used LRU underscore cache, basically the Python's tool of creating automatic dictionary. Okay, then we also created our own memoization trick. Okay, we wrote the recursive approach, then we also wrote the pure DP approach. Okay, so I think this question is pretty much clear now, and thank you so much for watching the video. And if you have some comments, if you have some doubts, you can type in the comments. And also, if you want me to improve anything, my setup, maybe my English, maybe my language, maybe my accent, I am happy for taking your inputs, because real growth is basically, sorry guys, actually I can't think of a good dialogue right now because it's night, and maybe I should just go out and have my Zada session. Okay guys, so I'll sign off, and if you have any doubt you can type in the comments. Thank you so much.